All right, this is McGraw-Hill Chapter 7, Section 3, Solving Quadratic Equations. This is different than what we've done before because this gives you some new techniques, especially in terms of college algebra. This is example 1, page 606. It says parentheses 2x squared minus 5 squared minus 16, parentheses 2x squared minus 5 plus 39 equals 0. Well, if we turn around, you'll notice that we have 2x squared minus 5, 2x squared minus 5. So if we make u equal 2x squared minus 5, then what happens is this becomes u squared, this becomes 16u plus 39 equals 0, which makes it much easier to factor. We'll substitute this back in the end. Okay? So what happens here is u squared minus 16u plus 39 factors into u minus 13 times u minus 3. Now we take u minus 13, we set it equal to 0, but we substitute back in 2x minus 5 for u. So see, u became 2x minus 5 minus 13 equals 0. U minus 3, we substitute 2x minus 5 in for u. So u minus 3 equals 0 becomes 2x squared minus 5 minus 3 equals 0. Now we just solve. Minus 5 minus 18 minus 13 gives us 2x squared minus 18. Add the 18 over, divide by 2, we get x squared equals 9. Take the square root of both sides, we get x equals plus or minus 3. Here we get 2x squared minus 5 minus 3 equals 0. Combine like terms, we get 2x squared minus 8. Add the 8 over, divide by 2, we get x squared equals 4. Take the square root, x equals plus or minus 2. So all we're doing is we're setting the problem up as a quadratic, but because we have the same term in the square and in the single x, we're substituting u in there, and then we're bringing it back at the end. There's another example. Okay. First of all, starting on this side, it says p to the 2/3. Oh, I forgot the sign there. That should be a minus sign there. P to the 2/3 minus 2p to the 1/3 equals 8. So we do a couple of different things here. So that should be a minus. So that should be a minus here. Okay. So make sure you understand there should be a minus here. So we change this to p to the 1/3 squared, because we just bring the 2 outside, minus 2p to the 1/3 minus 8. And now what we do is we substitute u in for p to the 1/3. So this now becomes u squared minus 2u minus 8. This factors into u minus 4 times u plus 2. Now we're going to take that p to the 1/3 and put it back in for u. So we get p to the 1/3 minus 4 equals 0. We get p to the 1/3 plus 2 equals 0. Then we come over here and realize that p to the 1/3 is cube root of p. So it's cube root of p 4. So we cube this side and cube this side, we get p equals 64. Realize that p to the 1/3 here is cube root of p. So we cube p, cube -2, and we get p equals -8. Coming here, this is example 3, page 607. We have x minus square root of x minus 12 equals 0. Well, you know the square root of x is 1/2 power. So what we're going to do is put this as 1/2 power. Instead of x to the first, we're going to write x to the 1/2 squared. This power rule says if we multiply exponents by another exponent, we multiply. Well, 2 times 1/2 is 1. So what we're going to do is make u equals x to the 1/2 power. So this becomes u squared. This becomes u minus 12. This factors into u minus 4 times u plus 3. Substitute back in for u x to the 1/2 power. We get x to the 1/2 power minus 4 equals 0. X to the 1/2 plus 3 equals 0. Add the 4 over, we get x 1/2 equals 4. Realize 1/2 is square root. Now we got to do a square both sides. We get x equals 16. Subtract the 3 over, x to the 1/2 equals -3, which is square root of x. This can't happen because we can never have a negative value inside the square root. So therefore, square root of x equals -3 can't happen. Square root of x is always positive. Last example problem. We have 4x to the fourth plus 7x squared minus 2 equals 0. We can factor this straight up. And so what happens is it becomes 4x squared minus 1 times x squared plus 2. So you look, when you multiply the outsides, you get a positive 8x squared. Multiply the insides, you get a negative 1x squared. 8x squared minus 1x squared is 7x squared. So we've just factored it. All we do is set these equal to 0. 4x squared minus 1 equals 0. Add the 1 over, divide by 4, take the square root, we get plus or minus 1/2. Here, take the x squared plus 2 equals 0, subtract the 2 over, take the square root of both sides. We've got a negative in there, so we're going to get imaginary, bring the I out, so we get plus or minus I squared root of 2. So these are examples of more advanced quadratic equations you have to solve, and there are different techniques that you have to use.